Hi everyone, we're going to go through the dilution worksheet answers in this video. All of the questions on this are MIVI equals MFVF problems, so that makes it a little easier. But we do want to be on the lookout for, in the checkpoint for 8.1, we're going to see these problems mixed up with the previous ones, where we were just looking at the M equals N over V calculations, and occasionally we'd need to convert from grams to moles of solute, and it always needed to be in liters. Here you'll notice that as long as you're consistent as to whether your volumes are in milliliters or liters, then you can keep volumes in milliliters. For instance, here I took 100 milliliters, converted it to liters, and when I got a final answer here, that answer was in liters, so 0.0313, and then I rounded that to 3 significant figures and gave the answer in milliliters here. This question is asking for the initial volume of stock solution needed, which is a pretty common question we need to answer in the lab. How much of that stock solution should I start with? Another common question is what's the final molarity if I take a certain initial volume of the stock solution, like 15 mils of 18 molar acid. If I dilute it to 1 liter, we can calculate the final molarity this way. MF equals MIVI over VF. And again, careful and make sure that your units are compatible. Here I've chosen 15 milliliters and 1,000 milliliters. I could have also chosen to give the final volume as 1 liter, and the initial volume was 0.015 liters, and I would get an answer that's, again, the same since liters cancel. So just be consistent about what units for volume you're using. Let's look at the next two questions. So in question 3 and 4, again, the first one, we're solving for initial volume of stock solution needed. I went ahead and put the volume in liters in the problem, and then I got an answer in liters as a result. I could have also put the volume in milliliters, and then I would have gotten my answer in milliliters to begin with. As long as we're consistent and we're keeping track of where the units are canceled or not, then we'll be able to either use milliliters or liters. Here, it says when 10 liters of water are added to 3 liters of solution. Notice that the final volume will not be 10 liters. Of course, if I add 10 liters of water to 3 liters of something else, I'm going to have 13 liters of solution. So make sure here you're dividing by 13 and not dividing by 10. It's very easy to get the final volume of the solution mixed up with the volume of water added. Okay, let's look at the ones on the back. This first one's pretty straightforward. How much initial solution or stock solution do you need in order to make 2 liters of 3 molar solution if your stock is 12 molar? Simple calculation gives us half a liter. Now, there was a typo in question number 6. It meant to refer back to 5, and so I gave everybody credit for this question since some people were confused about how it could possibly relate to number 7. So let's just make sure we understand this, even though everybody got credit for it. If you start with half a liter of solution and you want to dilute it to 2 liters, of course, you're going to need to add 1.5 liters of water. So a question that comes up occasionally is, okay, well, how much water do you need to add? You don't add 2 liters, right? That's the final volume we want to get to. We need to take that final volume, subtract the initial volume to get the volume of water that is added. Last but not least, we'll look at questions 7 and 8, and it says these are different because in this case we're mixing together 2 solutions. We'll call them solution A and solution B. One of them is 2 liters and one of them is 4 liters. So of course we'll get 6 liters in all. But how am I going to get the molarity of this new solution? I'd need to know the total number of moles as well as the total volume. Well, we can use the formula N equals mV for each solution. N equals mV gives us the molarity of the first solution. 2 times 3 is 6. And N equals mV can give us the molarity of the second solution. 4 times 1.5 is also 6. So 12 moles of solute total divided by 6 liters of water. In the last problem, we're asked, what if I had an additional 4 liters of water there? Of course, if we add water, it's not going to change the number of moles of solute that are present. That's still 12 moles. But we'll now have 10 liters of water. So the concentration is 1.2 molar. So let me know if there's questions, and we'll have a class meeting today on Friday where we'll talk about these a little bit more and the 8.1 checkpoint.